make a start? Good morning and welcome to our latest installment of Solutions for Success. I'm Jonathan Hamilton from Point Alliance, and our topic today, Microsoft SQL Server Dynamic Data Masking Policies. So dynamic data masking was introduced in SQL 2016 and has many features and capabilities that can make your life easier and better as you're doing development, as you're sharing data, perhaps between an organization and a development team, as you're looking at sharing data on premises in the cloud. And we are lucky enough today to be joined by Jan Crow, one of our leading solution architects at Point Alliance. And without further ado, I'll turn it over to Jan, who can take you on a tour and a deeper dive on this interesting topic today.
Good morning. Today we'll be reviewing dynamic data masking, which is a new security feature introduced in SQL Server 2016. It limits the access of unauthorized users to sensitive data at the database level. There are a few use cases for this feature. For example, allowing the application developers to access production data for troubleshooting purposes and preventing them from accessing sensitive data at the same time without affecting their troubleshooting processes. Another example is a call center employee who will access customer information to help him in his request, but the critical financial data such as a bank account number or credit card number will be masked to that person. And another example would be an appropriate data mask to protect personally identified information, such as a social insurance number or a birth date. A developer can query production environments for troubleshooting purposes without violating those compliance regulations. Dynamic data masking, also known as DDM, is a very simple security feature that can be fully built using T-SQL commands, which are familiar to the developer, easy to use, and also flexible to design. This data protection method allows you to determine sensitive data by field in order to configure the suitable masking function to hide it from queries. This feature requires no coding effort from the application side or encrypting of the data or applying any change to the real data stored on the hard drive. Dynamic data masking masks the sensitive data on the fly to protect sensitive data from privileged users using built-in or customized masking functions without preventing them from retrieving the unmasked data. Dynamic data masking helps prevent unauthorized access to the sensitive data by enabling you to specify how much sensitive data to actually reveal with minimum impact on the application layer. DDM can be configured on designated database fields to hide sensitive data in the result sets of queries. With DDM, the data in the database is not changed. DDM is easy to use with existing applications or business intelligence tools, since masking rules are applied in the query results. Many applications mask sensitive data without modifying existing queries. To implement DDM, first you need to specify your sensitive data, the role to mask it, and specify designated privileged users that have access to that sensitive data. And the next step is to select and implement a masking function. Let's walk through the main types of masking functions that can be configured in dynamic data masking. The first type we'll look at is the default. The default function that masks the data according to the field data type if the field data type is binary, var binary, image, single byte of binary, a value of 0 will be used to mask that field. For the date-time data types, the default is January 1st, 1900 at midnight value with that will be used to mask that date field. If the data type of the mask field is one of a numeric data type, a 0 value will be used to mask that field. For any of the string data types, 4 X's will be used to mask that field. If the field length happens to be less than 4 characters, less number of X's will actually be used in its value. The second masking method is the email function. The email function is used to mask fields that store an email address. The email function shows only the first character of the email address and masks the rest of the email, same as xx@4x's.com. The third masking method, which exposes the last 4 digits of the designated field and adds constant string as a prefix in the form of a credit card. The random masking function is used to mask any numeric data type by replacing the original value with a random value within a range specified in that function. And the last masking type is a custom function. That allows you to define your own mask for the specified field by exposing the first and last letters defined by the prefix and suffix and add a padding that will be shown in the middle form in the form of a prefix padding value, suffix taking into consideration that part of the prefix or the suffix will not be exposed if the field's original value is too short to be masked. Like any feature in SQL Server, there are a number of limitations for the dynamic data masking feature. For example, you can't define DDM on an encrypted column, a column with file stream, a column set, or a sparse column that is part of the column set. Computated columns or key columns in a full text index also cannot be masked. Also, if the column is to be marked part of an index or any type of dependency, we should drop that dependency, configure the DDM on the column, then create the dependency again. Also, DDM will not prevent privileged users from altering the masked column or modifying the masked data, however. Let's take a look at how to configure DDM feature practically and how it works. Assume that we need to mask an employee's critical data in order to prevent the developer who is responsible for developing and troubleshooting that system from viewing that sensitive data. First, we will create an employee financial table and add some data to it. As you can see on the screen, that we have the data structure in place, and I've already created some data for this table. We're also going to create a user that will have read-only access to that table. Now, if that user tries to retrieve all employee sensitive information from the employee financial table, they'll be able to see the entire table's results because we haven't applied any data masking rules yet. And as you can see on screen, that all fields are shown from their employment date, their email address, their name, and their birth date. To overcome this disaster, because we obviously don't want to share all this information, we will mask the critical information gradually and see how this user will see that data. First, we'll mask the employee's last name using the default masking function by simply using the alter table, alter column T-SQL syntax. So we're going to alter the table employee financial and alter the column and set the function as default. And as you can see, the result set when they select from that table as that user, that the employee last name has been replaced with 4 X's. Next, we're going to actually mask the email. So we're going to use the mask with function as email. And you'll notice that the email field in the result set when they query on the data has been modified, but it has not been modified in the database, only in the result sets that have been presented to that user. Next, we'll take a look at masking the employee's salary, and we're going to use the random function of between 1 and 9. When you execute that function within SQL Management Studio query window, and then select from the table, you'll notice that the employee's salary column has been randomly modified from the original. And that again is only in the query result sets. We have not physically updated data in the database. Let's take a look at a custom data masking example. We're going to use a custom function on the first name, and we're going to only show partial. We're going to add some XXX values. So we're going to show partial 3 characters. And as you can see, if an employee's first name was 4 characters or less, it's showing 4 X's. And in the case where their name is longer, it's showing a prefix of 3 characters of their real name and showing the last 3 characters of their first name and then replacing the rest with X's. Again, that is in the result set only. As mentioned before, no physical change performed on the data stored in that table. The users can be able to see the masked data if they are granted unmasked access to the database, which can be revoked quite easily. So these masking functions come in very handy also, not just in a developer's case, but in a business intelligence case, if you want to give somebody access to analyze certain pieces of data but want to hide personally identifying features, you can use the same masking functions. And when they use their business intelligence tools to query the database, that information will be masked and not limiting their ability to actually analyze the pertinent data or making coding modifications to hide columns for certain sets of users. Now, if you want to take a look at what columns are masked and what are not, there's a table that actually stores that information. And it is the sys.mask columns table. And you join it to the sys tables. These are system tables that define the tables and columns in the database. And as you can see, the 4 columns that we actually put mask functions on, they return those column names and what mask function was applied. So if we want to remove a data masking, all we have to do is use the alter table, alter column syntax again, and use drop mask after specifying the column you want to drop the mask from. And once you drop the mask, now any user can view that employee's first, in this particular case, first name using their account after dropping the defined mask. As you can see that the first name is showing now after we drop the mask. One thing to note is when there's a mask placed on the data, if somebody's trying to copy that data or export it using any of the export tools, the masking rules always apply because those are all query result sets. Whether you're using a select into a table or inserting with a select command or using SQL Server's import export wizard or using SQL Server integration services, as long as you're logged in as a user who has a mask applied to their role, they can't get access to the sensitive data. Now, the downside of data masking is stored procedures can't be dynamically masked, and this is because their execution algorithms are stored within the database, and client applications just request the execution according to an already existing plan. Thus, masking stored procedures requires rewriting the query results, not the query itself as just the query results. The DDM process is transparent from the application, where no coding effort should be performed at the application layer. You can choose the most suitable masking function for each stored sensitive data in your test environment and replicate it to the production environment. If you find everything is working fine, then it'll work out great. The dynamic data masking has its shortcomings. Stored procedures can't be masked, as I've mentioned, and it's not just because the execution algorithm is stored within the database, but also because it's often executed as a database owner, and therefore the database owner has access to all the stored data in the database. Like the biggest conclusion for this is this really allows you know, an environment to be set up in production without having to duplicate it into another database, and allow users to be able to use analytics tools, reporting tools against the data, doing queries, and really not worrying about sensitive information being exposed to those particular users, or having to do a lot of extra development work to have to hide that information, whether it's from a business intelligence user or from a developer or from a call center rep or any other type of user that shouldn't have access to sensitive data, and thereby reducing the amount of infrastructure overhead of having to replicate and create a read-only database that only has a limited set of data, and having to have different rules with different sets of data, because you could have multiple roles where some users have access to some sensitive data and other users have access to none, and some have access to all. And if you just create masking rules for each of those roles of users, it's much easier than having to create copies of the database or add a lot of programming effort or creating a bunch of brand new views for each user. And that way they can create business intelligence models they can share and not have to worry about hiding information that their audience shouldn't actually see. So that's data masking. There's one other feature that ended up not being released, and that's actually called static data masking. And I didn't go into it a whole lot today because it's not available yet. It was only available in SQL Server 2019 preview. And that was the ability to create a mask on a set of columns and be able to use that in a backup and restore that database backup elsewhere. But as I said, that feature is not currently available. So thank you very much. If anybody has any questions.
Thank you, Jan. That was great and very informative. I think you provided everybody with a number of possible use cases of how they may make use of this feature whether it's for data sensitivity, as you mentioned, within an organization, or data sensitivity between organizations, or between an organization and a development shop. Again, lots of good stuff there. So thank you very much, Jan Crow, Solution Architect at Point Alliance, and Rockstar. And I think that is it for the day. Thank you so much.